Number 15, shown above is a clock at time 10:10. The length of the minute hand and the second hand are each 5 inches. So I'm going to go ahead and underline that. That's something important for this problem. Use the center of the clock as the origin of the coordinate plane with 1 unit equaling 1 inch. Find the coordinates for the tip of the minute hand. So find the coordinates for the tip of the minute hand at time 10:10. So basically we're just trying to figure out, okay, what is this coordinate right here if we were to, again, imagine that this is like our coordinate plane. Okay? Well, a couple things I'm going to do first. We assume that the 1, the 2, the 3, the 4, etc., all the way up to 12 are equally spaced out. So, since that forms a circle, and there's 12 points on the outside of our circle, I'm going to say, okay, well, each movement, each space in between like 1 to 2, 2 to 3, etc., that angle that's in between these values here is going to be 360 degrees divided by 12. So you do 36 divided by 12 and get 3, but we have a 0 in there, so each angle in here, formed by just moving the minute hand to the 1, the 2, the 3, etc., is a difference of 30 degrees. I also want to note that they tell us the radius of each of these hands, or the length of each of these arms, are 5 inches. So, well, if this is a regular old unit circle, I know what the coordinate of 30 degrees is. The coordinate of 30 degrees is just square roots of 3 over 2 and positive 1/2. But, again, they tell us that detail that the length of the hand is 5, so we have to multiply both of these values by 5. So this gives us a final answer of 5 square roots of 3 over 2, comma, 5 times 1/2. You could write 2.5, or I like to keep it as fractions, 5/2. So that's the coordinate of the end of the minute hand at time 10:10. Number 16 says, what is the measure of the angle formed by the second hand and the minute hand at time 10:10? Assuming the second hand is at the 10 o'clock mark. So basically it looks pretty similar to our picture that we already had in this problem. But we all know that this is the hour hand here, and this guy down here is the second hand. But what they're saying is that the second hand is now, my pen here, the second hand is directly on the 10. It's perfect. And it's going to go to the center. So we want to know the angle that's formed in between here, that whole thing. Okay. Well, we already got done saying that each movement of one of these hands or arms is going to create a 30-degree angle. So if we kind of just rotate through this angle, I mean, it's pretty easy. If we rotate from 2 to 1, that's 30. Another 30, 60, 90, 120. So this big angle in between here from number 16, the angle that's formed there is, again, just 120 degrees. So no real hard math there. And just a reminder, sometimes they might ask for it in radians. So 120 degrees is 2 pi over 3 radians. So either one of these answers would be acceptable, unless they specifically ask for one or the other. The last problem in this review packet says, how far does the tip of the second hand travel in 45 seconds? leave your answer in terms of pi. Indicate the units of measure. Okay, so 17. Again, we want to know how far does the tip of the second hand travel in 45 seconds. Well, if you think about that logically, okay, 45 seconds is 45 seconds divided by 60 seconds, or 3/4 of the way around the entire circle. It doesn't matter where the second hand is actually starting or stopping, it just matters that it has gone 45 seconds. So maybe it went from 15 seconds to 60, maybe it went from 5 to 50 seconds, but as long as that distance traveled is, or that time traveled is 45 seconds. So I know that it says leave our answers in terms of pi. So I'm going to not use degrees, I'm going to use radians. So I'm going to say, okay, 3/4 times 2 pi, because that's the entire way around the circle. What does that equal? Well, the 2's cancel out, right? 3 times 1 times pi gives us just 3 pi over 2. So maybe you got this answer without even doing that math, or maybe you can just kind of picture on the unit circle 3/4 of the way around is 270 degrees, or 3 pi over 2. The next thing I'm going to do, since it said how far did the second hand travel, I'm going to use the arc length formula. So just a reminder, again, something that is going to be important in our exam is knowing this formula. Really simple. It's r times theta. S represents the distance traveled around the circle. R, I think that's kind of obvious, that's our radius, which we're given in the problem. And theta, this is really important, it's our angle in radians. So do not put a degree measure in here. Do not put 270 degrees in here. Put 3 pi over 2. And there's kind of a hint in the problem to leave it in radians just because it said it leave it in terms of pi. That was kind of a key thing in this problem. Okay, so anyways, moving on, I'm going to simply plug in my values. So S equals 5 times our angle traveled, 3 pi over 2. And we get 15 pi over 2. We want to include our units, so 15 pi over 2 inches. Now, an approximation of this, just to kind of give everybody a better idea of what that means, just simply take 15 pi divided by 2. Let's see what that comes out to. So it goes about 23.5 inches approximately. So it kind of just gives you a better idea of what we're talking about. But again, they told us specifically to leave it in terms of pi, so I'm just going to leave it like that, but just so you have a better understanding of what that number or what that value actually means. Okay.